Hello everybody. So they just closed the door. Welcome to this session about NeuVector, and lucky us, they made exactly at the same time another session about NeuVector. So I hope you pick up the right one. I don't know why they put it at the same time, but anyway, my name is Giulio Todini, and I'm a solution architect in SUSE, and this young fellow here is Giovanni Lovecchio, and he's a support engineer in SUSE, and it takes care typically about NeuVector and things related to ECM world. Okay? So this is the topic: automate NeuVector federation across diverse cloud providers. And let's see what this is about. So the idea is to speak about the Kubernetes security challenges. I know that most of you maybe already knows everything about that. Otherwise, you weren't here. But I want to be everyone at the same level, or at least speak the same language. I will try to explain why, in my opinion and in the SUSE opinion, NeuVector is the answer to the challenges. And then we will speak about the nice, multi-infrastructure that could be having cluster to be protected everywhere in multiple clouds. That is one of the use cases where Rancher and NeuVector, are the best. And thanks to Giovanni, then let's say how to automate everything. And so the nice part of this talk would be that he will share with you a Terraform already built up that you can use later on. But the nice part is that we will show the automation on what you get. But the nice part, in my opinion, is that he is going to show 3 use cases about clusters that are over 2 hyperscalers and that are federated. So you actually see what you can do when you have multiple clusters and how to protect them in a federated mode, okay? And then, of course, question and answer. But anytime you want to ask a question, let's do it, don't worry. The only caveat we have is that you have to use the microphone, so we will give you a microphone because we need to record the question. Otherwise, that's just the answer in the video, okay? So, Kubernetes security challenges. Let's start from here. Most of you saw this picture many times, but when we start discussing, which are the challenges in the world of Kubernetes, they come from the nature of the pods that are managed inside Kubernetes, right? Let's think about the traditional approach. You have a sort of castle, right? You have a wall, the typical firewall that protects your data center or whatever. In this case scenario, you trust whatever is inside, you don't trust whatever is outside. When you speak about Kubernetes instead, basically what you do is that you delegate to Kubernetes the management of the pods, whatever is in the castle. So that's very cool. It takes care of a lot of things, but it's hiding the network to you, right? So basically you are in a castle, you built up the wall, but then every single house of the villagers are actually point of failure. They can jump into inside your castle from everywhere, right? Because the network, every pod, every house is actually in the network, okay? So first thing you have to think about is that you can't think in this way because you are missing a point. The nature of the pods inside Kubernetes is that they are ephemeral. If they are written correctly, they just jump in when you need the function, they work for what they need to do, and then disappear, right? So again, the network is dynamic. The features that are in the network are completely dynamic, right? So you need to take care of that. Again, a traditional approach let you miss that. And of course, everything in the infrastructure as code or Kubernetes is thought to be automated, right? So you want also that your security is automated as well, or at least you don't have to think about it. You need a method that works as a security as code, let's say, right? So what is the modern approach, let's say, to take care of these? We step back from the castle, and we think about protecting every little house, right? So we start having that the park inside the big wall of the castle is a place that is not trusted anymore. You don't trust it anymore, and you build your own wall all around the houses, right? So you need something that allows you to protect every pod and take care of what happens in the east-west traffic, or whatever you call it, the one inside your cluster. So the idea is that NeuVector is the way, right? There was a Mandalorian thing that should be, in the background, but it's not working. But anyway, can you think about in your head if you saw the TV show that this is the way with the Mandalorian voice, but didn't work. Anyway, so what are we going to do? So basically, the idea is that we are thinking about an end-to-end application protection with NeuVector because what you saw, basically, it was a picture of a cluster that was a running application. But what you want to do in the cloud-native approach is that you want to protect all the pipeline, right? You want a software supply chain security that is actually covered by your security software. So you start from the real pipeline, from the creation of the image that you want to build. You can scan the registry and go further, right? So you need an end-to-end protection that starts from the software supply chain to whatever is running. And then, as we said, you need something that allows you to scan and protect the actual containers, right? And then, again, you need an approach that is zero trust. So you need to be sure that nothing can impact on your system. So, as I said, the NeuVector typically manage the two things as described. And you can see here basically two areas. The first one is the one I just described about the end-to-end, that is more on the DevOps part, right? So you know the threat, you know what is going on, you know the CVEs, you look for them, you know the compliance that you need to be, compliant to, and you look for that. And then in the pipeline thing, you scan the registry and you reach out, the opportunity to have an admission control. So the admission control is actually a bouncer. You are in a disco, you are not dressed correctly, you don't go in, right? So the bouncer has some rules and actually check the rules that you set up. It's a CVE, number of CVE, severity of the CVEs, whatever you think. You have a very complex way to design, it's a simple way to design rules that can be very complicated, and that your admission control in NeuVector. And you can scan everything based on threat that you actually know up to the runtime. So you can actually verify everything also on everything is running on your cluster. The difference here is that there's another part that only NeuVector can do actually today, that is the runtime zero trust approach that is based on a specific algorithm that actually was patent in US. Because something that I didn't tell you yet is that NeuVector wasn't open source at all, right? It was a private software, so we bought it as SUSE, and we developed the 5.0 version that is actually open source. So we develop and support an open source solution, so now that patent algorithm is open to everybody, but it's actually different from anything else, and is a deep package inspection patent algorithm, okay? How that works? Basically, the idea is that you can continuous monitoring what's going on. You basically have an enforcer that is able to, it's called enforcers, but it's a daemon set, it's a container that is actually in your cluster and is able to inspect the network. So you have the traffic of the network inside your cluster is the truth that NeuVector is using to understand, your application. And what this algorithm is able to do is that it's able to learn from your application everything related to what? To processes that are running, to file that you open. But the cool part is that it's able to understand and to monitor all the application protocols. So the famous layer 7 of the OSI, right? So these allow you to get for free and immediately the creation of an allow list, okay? So you have a list of rules that actually map your application, right? So the cool part is that in the Kubernetes world, you can also export all these rules in a YAML file that you can actually add and provide to your developers. So basically, the developers can immediately deploy the application with the policy attached to it on the next cluster they want to deploy the application on, right? So basically, you have automation, you learn from the application, and you have this zero trust approach. And why this zero trust approach is important? So I like to explain it in this way. Let's say everyone maybe is familiar with this CVE, the zero-day CVE, right? So it's nothing that you can do about them. Apart from the fact that if someone is using actually a CVE, a zero-day CVE to log in or to take control of your containers, let's say that you have a list of things that your application should do, and you actually use it to protect your environment. Anything the hacker or the person that is trying to do is basically only what the application can actually do, right? So this is the way NeuVector protects you for something that is unknown. It puts you in a condition that no matter what, no matter if you have the fix or not of that CVE, the point is that no one can do anything apart from what the application is meant to do, right? So that should bring you on the safe side. And that's one of the peculiar things of this software. So how it works, this deep package thing, basically NeuVector works in 3 modes. So you have the first one, that is the default. So as I said, you have a cluster, you have all the traffic running, and NeuVector is able to discover, right? This is the mode, and learn from the application. Whenever you think your NeuVector learned, basically you can switch to monitor. That is actually a mode where you apply your rules and you identify behavior that are considered anomalous. Basically, they are not in the list. But you don't stop them, you don't block the behavior, the anomalous behavior, you alert the system. So it allows what's wrong, but you get an alert. The most rigid mode is this one, is the protect one, where you actually block that specific package, okay? And the cool part is that you're not actually putting the container in quarantine or kill the container. You just block the package that is passing through, okay? So you get an alert, you block the anomalous behavior, and that's it. Everything is completely blocked, okay? Everything is clear up to now? Cool. So NeuVector is the way, as I said, and is the answer to all your problem. But what about if it's more complex than one cluster? So actually, it's not a big deal. Let's say that you have several clusters on, for example, on hyperscaler, AWS, for example. So here you can see there's EKS icon here, but it doesn't matter. Basically, NeuVector is able to work on any Kubernetes cluster, but in particular, it's not related to Kubernetes. It's just related to the container engine. So it can run on Docker-D, on CRI-O, or Container-D. So it's not, of course, in this case scenario, we are speaking about Kubernetes, but it's more than that, okay? So let's say that you have this situation, and you install NeuVector on each of these clusters. The problem you have is that basically it's one NeuVector for every cluster. So basically it's not very comfortable with the fact that you have to configure every policy for every cluster, right? In NeuVector, actually, you can federate them. So what you do is that you assign to one cluster the role of admin, and so in that case, you can manage from one single interface all the cluster, and you can derive the policy from the primary to all the sons. Okay? So in this scenario, it can work on this, like with one hyperscaler, but of course, you can do it from the same primary on both. 2 different hyperscalers, several clusters, different distribution, right? So this is the scenario that we thought. And if you can think about having a huge number of clusters, of course, the idea is that can be tricky to set up this environment. And in fact, the question is that, do I need to install NeuVector on any cluster manually and then federate them? In theory, yes, that's the path, but no. Lucky us, there's Giovanni that wrote the Terraform for you. So that's, that's why you're here. And so the idea is that we automate everything with the Terraform. And just for the purpose of these, the idea here is that, oh, a piece is missing. Okay. The idea is that the Terraform that Giovanni is going to share, and the use case is about, of course, one primary on Google that is managed as secondary on Amazon EKS, but of course, it can be scalable as much as you like. Okay? So now I will let Giovanni continue.
Thanks, Giulio. Hi, all. Now, given that the demo cannot be done entirely live due to technical times required to deploy the Kubernetes clusters, we created a repository containing all the steps necessary to replicate what has been done and what we show during this talk. I'll give you some couple of seconds to scan if you want. Okay. Let me switch to the README file. It's a simple README file that contains a brief summary of what Giulio explained until recently, the useful links to retrieve the Terraform code, okay, and all the steps necessary to replicate here with the demonstration chapter to replicate the laboratory in your environment if you want. The Terraform files are located in two repositories, okay? One that contain the modules, which are the templates that we used to deploy our GKE EKS clusters, okay? For example, for AWS, into the directory you can find all the preparatory steps that can help you toward the authentication on AWS, and inside the templates for EKS, okay, with all the resources that we need to configure when we have to deploy an EKS cluster. Same, of course, for Google Cloud, okay? And another one, this one, NeuVector TF Federation, that contain the main file with all the configuration that we made to create this laboratory, okay? With, for example, here, the primary, the GKE cluster, the call of the modules that we used to deploy the GKE cluster, and all the other resources necessary to deploy NeuVector, okay? Everything's from the day zero, okay? The concept of security from scratch in the deployment phase. Okay, what are the steps that you have to follow to deploy everything in your environment? Simply pull the repository, the NeuVector TF Federation, this one, that have everything already prepared. Configure the two Terraform vars files, one for GKE and another one for EKS, configuring the minimum necessary variables that are a prefix, a project ID only for Google Cloud, and region, and the NeuVector password. And then copy and paste what is present into the README file, okay? Into the README file of the projects that are all the steps that you have to follow to apply the Terraform files and set up the federation. Obviously, there is much more that can be configured. For example, you can extend the parameterization of GKE EKS cluster by uncommenting all the prepared variables, such as the number of node or I don't know, set up a specific VPC or subnet. The other resources, as we said before, are only for the setup of NeuVector. If you want to create multiple clusters, simply copy and paste the directories, like remote EKS, and change the prefix, okay? This allows you to create how many clusters you want. Let's imagine putting these things into a CI/CD pipeline or Jenkins file to deploy all the clusters that you want. For the NeuVector federation, however, you will have to modify this file, the setup NeuVector federation.sh, by adding the variables that contains the NeuVector IP and password, and copy and paste the portion of code from line 33 to 41. Otherwise, of course, you could re-engineer the script, automating several steps. For example, a for loop can be used to understand how many clusters have prepared to set up the variables dynamically, and another do while loop can be used to join the cluster to the controller, okay, to make this script dynamic. Okay, I think we reached the point where we can log into NeuVector. We already created the clusters, so we are, if you are following, the lab from your mobile phone, we reached this point, okay, when we deployed everything and the two clusters are created and was created and available. Okay. Here the password that I set up for the laboratory. Okay, here we go. Here we are into the controller cluster. We can double check very quickly, simply going into the nodes and looking for the operating system, for example. Here we have the container optimized for Google Cloud. And if we switch to the worker cluster, we can see Amazon Linux 2. Okay, that is the operating system for the AWS, for the EKS nodes. Of course, from the controller UI, we have the control of all the feature, all the NeuVector functionality of the worker cluster. So we can do everything here, okay, whatever we want. And nothing. I think we reached the point also when we can moving forward to our use cases. As Julia anticipated, we have prepared 3 use cases, okay, to show you how federated policy are used. For the first case, it's necessary to activate the admission control on both clusters and configure a federated registry to scan images that contain a specific CVE that serves as an example. Okay. To enable the admission control, it's very easy because from here, policy admission control, tac, enable, switch to worker and enable. Okay, done. 1 second on both. And as for the federated registry, we have already created it because some time is needed to the scanning, so we prefer to do it before the presentation.
I stop you a second while you do this.
Okay.
So everyone is following, right? So the admission control, we are testing the bouncer. So this use case is that you have 2 clusters. You have the controller managing everything, so you can switch every time, but you can set up in the controller, and you define the rules to accept or not an image coming from a registry, okay? Based on specific rules. Okay, sorry, just to give you time for...
Thank you, Julia. Okay. As I'm showing you, we took the elastic/log/star Docker images as an example because we know that one or more of them is affected by log4j vulnerability. After that, we can create the first federated admission control rule, okay, where we want to deny the creation of pods using images affected by the log4j vulnerability CVE 2021-44228. We do it in this way. On the corner of the controller cluster, we have the possibility. We have a menu where we can select the federated policy. Okay. Here we have all the policies available for NeuVector, but in a federated mode. It's only need to click to admission control, add, and create the rule. For example, demo 1. We said that we won't deny the creation of a pod that contains a specific CVE. Of course, I don't remember the name of the CVE, but I can copy it here. Oops. Okay. Okay. In a protect mode, that means that we won't deny the creation and not receive an alert or something like that, but deny the creation of this pod. Add. Okay. We can verify that the policy has been applied to the underlying cluster simply by checking under the policy admission control path. Here we go. You can see federated type, okay? So you can't modify the rule from here if you are not an fed admin user. Then we can test it directly through the CLI. We can try, for example, into the primary cluster. The Terraform modules create for us the kubeconfig, named with the prefix and underscore kube underscore config dot YAML. You can see something like that. Oh. Okay, here we are into the primary cluster. And now we can try to create a pod that runs an image affected by this CVE, for example. Okay. Error from server, admission webhook, blah, blah, denied the request. Okay. Of course, this generates an event risk report. Here we go. Admission control denied, okay? Is denied in per rule protect mode. Okay, is it clear, this first use case? Very good. For the second use case, we will create another federated admission control rule that denies the creation of pod in a specific namespace, for example, demo2. Okay, so let's do the same procedure, federated policy, admission control, add demo2, demo2. We said namespace here is one of demo2, for example, protect. Here we go. A double check just to be sure. Demo2 rule, okay, namespace is one of. Same for the worker. Okay. And now we can test it through the CLI as done before. Of course, space. We don't have demo2 namespace. Create demo2. Okay. And let's try. Okay. The admission control blocked us to do this. We have a notification too, of course. Controller, notification, security event, risk report. Admission control denied from this rule. Okay, guys? Good. Now, to prepare for the third and final use case, we need to create a pod on the worker cluster, the EKS1, where the core package is installed and make HTTP, HTTPS calls to any URLs. I have all the command, of course, here. Let me only change directory. Here, let's go into the remote EKS. Also here, we have the kubeconfig.
So while Giovanni create the use case, was clear about the federation rules has, of course, a priority that is higher than every other rule, right? So that allow you to coverage. The coverage is from the top. The federation rules are available as a first layer, and then you have the others, right? So you are always sure that when you control centrally, you send policy that are more important than others, so you're sure that they basically override whatever is below that, okay?
I'm changing to the G-key cluster because I didn't export the AWS credential. I can't take it now. So let's do the example on the G-key cluster. It's the same, okay? Okay. Okay, as we said before, let's create a curl pod just to have this image. Okay, here we go. And now let's run a curl to any URL we are trying with the NeuVector 1, the documentation just to do a test via HTTP and HTTPS protocol. Okay, 1 HTTPS and 2 HTTP. Okay, very good. Now here we should intercept into the policy network rules. We should intercept the calls. Refresh. SSL. Here we go. Here. Okay. NeuVector intercept the network traffic. Okay. Now, if we want to protect, for example, if we want to deny that our containers can reach external URLs through HTTP protocol, we have to create a federated policy, network rules. Okay, let's do it. Demo 3 from fed containers to external. Okay, application HTTP. Action deny. Add. Save. Okay, let's see how the rule was applied on the underlying clusters. Network rules. Okay. It's into the controller, same into the worker cluster. Okay, and then we have to configure the network security policy mode to protect in order to block the request. So settings, configuration, network security policy mode, enable to protect. Okay, let's submit the change. Very good. Okay, finally we can run the previously made curls again and see what happens. So let's start to with the HTTPS one. It worked. Let's do the same with the HTTP one. Hopefully the timeout should finish soon.
You should check in notification in the meantime. In events.
Yeah. Here. In any case, we received the alert from NeuVector. Okay? We have the security events.
The network rule was violated, so there's a deny there.
Here, the URL that violated our rule. Okay? Here. HTTP protocol. Okay?
Okay.
Very good.
So thanks Giovanni for the use cases. I don't know if everyone had the chance to understand and follow the things. You know, they were like pretty simple cases, I know, but it was just to let you see how easy it is to set up, but how strong is the federation and the fact that you don't actually care if the clusters are running on AWS, on GKE, Azure, on premises. You can just federate them, and as soon as you have an admin, you can manage them. Okay, so actually in the use cases, just because in the demo and during our session in the NeuVector Rodeo, we always show how to use the group rules that are actually those that are clear that they use the deep packaging. We decided to use different kind of rules. So first of all, any questions? Any doubt?
Thank you. Is there a way to because the first demo you've done, it was when you were trying to create a new pod. Is there a way to protect against, for example, access to a secret? So more get operation than create operation?
Yeah. So I don't know if you want to open the admission control. There are a lot of rules. You were mentioning the admission control, the first use case, right?
Yes, exactly. Let's say there is a sensitive secret that you want to be sure that no one can have access to.
Yeah, so there's the criteria that you can select are multiple, and you can go down to environmental variables with secret and other specific requests. So the level of complexity of building the rules is very strict. So.
But it's when you create, or you can ensure that he doesn't have access to the existing secret?
I think that it's related to the privilege, right? To the access to that. Okay. So yeah, you can actually block it. There are some bundles, but you can also take care of the privilege and what you can do, not the creation. Any other question, curiosity? Something related to the Terraform thing, the way we manage the NeuVector thing.
I have another question. Thank you. It's not exactly a question, but I can give you some mind challenge, but probably you will never invite me to this session again.
I think.
Do you accept?
Yeah, definitely. You know, I'm
can,
not the one that developed it. I'm just the one that showed it.
I can show you how to render NeuVector completely useless in Kubernetes cluster.
That makes sense. Why don't you sit down with our engineer and speak with them?
No, I spoke to them already.
And
nothing changes so far, but I think will change.
Yeah.
Yeah.
So there's a secret thing that they just learned.
This is not a secret thing.
No. I mean that they just learned that the guy that is developing Kubewarden, that is called Flavio Castelli, that he developed all the Kubewarden extension in Rancher, is having a look at the NeuVector code. So I expect that a lot of things you said maybe are already included in the future.
You know, because the NeuVector is very good in observability. Yeah, this network layout you can show. It is learning this layout, how the traffic works from the pod through this NeuVector enforcer pod and going to outside to external, internally and coming in. This is very fine, but let's look at some scenario.
Yeah.
We implemented new Kubernetes cluster. We implemented NeuVector on this cluster. NeuVector learned this layout of applications of the cluster, and our security team approaches us and says, we need to physically separate each application from each other on the cluster. Okay, we have a solution for that. Rancher project network isolation. We turn on project network isolation. What happens to NeuVector?
I don't know exactly. I expect that you don't see the segmentation of the network anymore from NeuVector.
It's blind because the segmentation of project network isolation is done in the CNA level. It is network level on the IP tables, or maybe in Cilium in another layer, not IP tables anymore. And the NeuVector as enforcer works in pod. So he doesn't see the project network isolation implemented through Rancher project network isolation, which is on the network policy level. It we are losing a lot of observability with turning on one simple thing in the Rancher, which is officially implemented in Rancher and supported in Rancher feature. The second thing, we what changed lately in a few past version of Kubernetes? The pod security policies was deprecated and removed in the 1.25 version of Kubernetes. It was replaced by pod security standards. Pod security standards is implemented on the policy level, and we have only two policies that matters. But we have, because unrestricted is not a policy, it is unrestricted, yeah? We have a baseline policy, nothing changes at all, but we have very fine restricted policy, which is best practice implementation for pod securities. And one thing that pod security policy in restricted level turns off, it turns off capability of doing netadmin. Netadmin is required for doing any injecting sidecars to our pods. So we are turning on pod security standards in the restricted mode. We cannot do any sidecar. And we must implement service mesh, Istio, for example. It is possible?
Yeah, Istio should integrate with NeuVector, but as you said...
Istio integrate with NeuVector if he can inject sidecar to any pod that is Istio, that creates Istio service mesh. But he can never do again this sidecar injection because pod security standards doesn't allow it. So what is the Istio solution? Istio solution is go to ambient mode. How ambient mode works? Ambient mode puts near enforcer, but below it, second pod that reroute all traffic on the network layer through this Z-tunnel Istio. This is ambient mode. No more sidecars. And currently, we have Istio with Z-tunnels, which encrypts all the traffic below enforcer. And enforcer is blinded because all the traffic magically changes from unencrypted to rerouted through one pod, which is Istio Z-tunnel, which is totally encrypted to end-to-end encryption, because this is what Istio does. And all the traffic between nodes, it's not recognized by NeuVector so far, because all the traffic to the nodes is from one Z-tunnel to Z-tunnel totally encrypted. And the second pass, NeuVector is rendered useless, because this observability doesn't work anymore. It is something that changed in the upstream of Kubernetes, that pod security implemented, pod security standards, that replaced pod security policies, but NeuVector must implement somehow coexistence with such changes, because in the few years from now, the clients like us, who are approached by our development team, we need a cluster. We need a cluster with Istio because we want service mesh, because service mesh have very good functionalities for development, for developers. Okay, we can give you such a cluster. Security teams, you must separate this application from each other. Okay, we have project network isolation, great. And we need some more security, but NeuVector is useless because it is blind. It's in such layout, in such cluster, it's totally blind. NeuVector must learn how to coexist with such layout.
I agree.
This is the issue.
I totally agree. Giuseppe? Any other question? No? Okay, so thanks, Giovanni. Was his first speech. You did a great job.
Thanks, guys. Thank you. Thank you.